Hi, everyone. This is Sebastian Traeger, Managing Director of Reliability Center, and welcome back to another episode of Reliability 4.0. As always, we're on a mission to help make the world a more reliable place, really through the power of using technology well, strategy well, and thinking through how we can build organizations that are more reliable. And today, I'm excited to be joined by Drew Hellyer with Aurizon. Drew, it's great to have you here. Right before we started, he mentioned to me that he is based in Australia. So it's a real treat for us to have someone from Australia as well. Thank you, Drew, for being a part of this.
Thanks, mate. Good to be here and looking forward to the chat.
Great. I do want to learn a little bit about you, but for our listeners who have never been to Australia, if they're ever going to go, where would you recommend they visit first? Or what place would you say they should spend time?
I'm in Brisbane, in Australia, which is in Queensland. And, Queensland is the tropical state. It's got barrier reefs in the north, beautiful rainforest, great outback, not far away either. Everyone's a bit more relaxed in Queensland because it's always sunny. Definitely come to Brisbane. And then when you're here, you can go south to the Gold Coast or you can go north to the Sunshine Coast. There's a place up there called Noosa, and it's one of the most beautiful places on earth. And further north than that, it's a place called Fraser Island, biggest sand island in the world. Absolutely glorious. You pop into Sydney as well. It's always worth a look.
Excellent. All right. So Brisbane. And so maybe 2032 at the Olympics is a good time to do that.
Correct. Yep.
That's great. I would love this podcast to be about Australia, but it's not. It's about something else. So we'll dive in. So tell us a little bit about Aurizon and then your role there. We'd love to learn a little bit more about what the company does and what you do.
Sure. So Aurizon is Australia's largest bulk freight railway. So we haul predominantly heavy haul railroading in Queensland where I am, and also in the Hunter Valley, which is in New South Wales. We do coal haulage, so metallurgical and thermal coal haulage. And then in Western Australia, we do iron ore. It's got a lot of natural resources. We've got coal on the east coast and iron ore on the west coast. And together they get shipped up to Asia where they make a lot of steel. My role in Aurizon, I'm the program manager or head of projects for the Central Queensland Coal Network, which is based here in Queensland. My factory is a 2,700 kilometre long railroad that basically sits over a geographical footprint, which is basically the size of Greece. And I looked up this morning, or similar to the state of Alabama. So,
wow, okay.
Yeah, I'd love to work in a factory where everything's in one spot, but it's not. It's spread out, yeah.
So just so I'm clear on this, you say that your plant or your site is over 2,700 kilometers. That means that you and your team have to have some capability of getting to that entire plant, if you will.
Yeah, we've got 6 strategically placed maintenance and construction depots, but we work out of the head office here in Brisbane, but we've got satellite offices around the state, and I've got a workforce that's sort of spread throughout the state, yeah.
Great.
But even then, if something breaks, it can take 3 hours to get to it. So, yeah.
Okay. Wow. I've talked to somebody else actually who they shipped oil, over huge distances. And so that's another challenge. You obviously do it over rail. What's one of the most extreme situations you found yourself in?
So when you're running a railroad, and our railroad is very, what we call dense, it sees a lot of traffic. So even though it's 2,700 kilometres long, if you put it all in a straight line, it's made up of 4 rail systems. So, the longest haul from a mine to a port is about 400 kilometres, okay?
Okay.
But we do nearly 180 million tonnes of coal out of Queensland every year. And so our railroad, we're seeing a train every 20 minutes and we run 24/7, okay? So, this is about reliability. And for me, reliability is not being closed or only being closed when you plan to be closed, okay?
Mm-hmm.
So the challenge with that is fix on fail is just not an option when it comes to my asset. I don't have the luxury of letting something break, which is going to disrupt production, and then send someone potentially 3 hours away to go and fix it. Okay. So, we make money from running trains, which is ultimately helping the supply chain deliver its coal. So as far as a challenge, a couple of years ago, we had a cyclone, or as you'd say in North America, a tornado, which bared down on central Queensland, and it was the perfect storm. It took out all 4 coal systems. And we have an area in our Goonyella coal system called Black Mountain, which is on the Great Dividing Range, which is the main mountain range in Australia. And you've got 108 wagon long, 2 kilometre long trains running down a hill. There's a lot of force at play. And that runs through a fairly steep mountain area that the cyclone actually caused a whole bunch of landslips, okay? So remote area, hard to get to, in a rainforest, in a national park, with the cyclone still going on, and our customers are already saying, when are you going to be open? And having to say to
Huh.
our customers, I actually don't know because it's not safe yet to send someone into that area to understand it. It took us 3 weeks to get back, which was the longest we've ever been shut.
Wow.
To the point where our customers in Asia were looking at alternate supply chains because they didn't want to turn their smelters off because they were running short of coal. So that was a prickly couple of weeks. Yeah.
So in that scenario, once you got back up and going, what did you do with the backlog of coal? Was there a backlog, presumably?
Well, there was. The cyclone sort of went a fair way inland, so a lot of the mines were disrupted. Coal can stockpile, it doesn't go off per se. So, the mines were definitely full of stuff. So as soon as we were back, we were running hard. The other thing is, our customers said, look, if you're going to build it back, make sure you build it back better. What can you do so that, if we have another event like this, even though it's a bit of a black swan event, it's really
Right.
not a common thing. So we did rock armoring, put in bigger culverts, made sure our access road was upgraded to be, paved, so it was all weather. There's a beautiful concrete road running through the middle of a national park now, just in case.
Okay.
Yeah.
Yeah, that's great. Love hearing these stories. I want to turn a little bit of our time to, you gave a panel, which was, I think, pretty interesting on the misalignment between asset strategy and company strategy.
Yeah.
And you wanted to basically convey to folks, your asset strategy is part of your company strategy. Just give us like a highlights of what the problem is and what you proposed as the solution.
Sure. So asset managers love their assets, right? We want to make sure that they are in good condition, they're reliable, they're getting the love they need, they're being maintained as they need to be. We want to have the workforce we want to be able to do that, and also the time to do that, and the capital. And when you're part of a larger organization that has shareholders and other economic drivers, sometimes what you want as an asset manager isn't aligned to what the customer wants from the asset. And that's really the disconnect we were talking about. And I was joined on the panel by Richard Barber, who was from Drax Power. And I think you've had another guy from Drax Power from North
Yes.
America on previously. He was from power stations, so, large industrial asset. Richard McDermott, who was from Heidelberg Materials, a concrete batching company. And Ruth Rawlins, who was from PC Airfoils, very small company, but make very high-end foils that go inside aeroplane turbines. And all of us talked about something that we've wanted to do as an asset manager. A piece of technology we wanted to bring in, or a sensor that we wanted to get a handle on. And, in Ruth's example, in a small company, it was literally, it's the end of the quarter, stop spending money. The conversation went to how do you make sure that we have a voice against the CFO and the other areas in the business that want to save money or spend money or expand. How do you make sure that your asset has a voice? And where we sort of resolved to is you really need to find a language that works across the organization. And, KPIs are great, but if you've got a KPI that tells you how good your asset's going, but doesn't mean anything to anyone else in your organization, as importantly, or maybe more importantly, your customer, then you're measuring, but no one's really interested in what you're measuring. Everyone gets interested when it breaks, right? Or everyone gets interested when it's not available. And you can say, look, I've been telling you for months that I've got a problem, but if that message isn't getting through, that's the real disconnect that you've got to try and find. As far as to what to do about it, in Aurizon, we've arrived at a number of KPI type metrics, which mean as much for me as a blower or an asset manager as it does for my train operator, as it does for my CFO, as it does for my customer. And it's a bit of a weird one. It's called usable capacity. Okay. So like I said, we run 24/7, 365. We've got a built capacity. So if everything's going perfectly, the railway should be able to accommodate X amount of tons. But then you've got to take in train dwells, loading and unloading. There's a whole bunch of operational things you've got to overlay that. And then you've got to overlay, how many hours do you need to take the railway out to do planned renewals and maintenance, which gets you down to what's called usable capacity. Once you take all those things into factor, your usable capacity might be 87%. So 87% of the time, 80% of that 365, 24 hours, 87% of the time we're open and available. And then it comes down to how often or how close are we getting to 87%. And if you're doing things which are eroding from 87% down, that's what we measure. Yeah.
So let me try to say that back to you to make sure I'm understanding it and make sure our listeners also understand it. I'm alive 365 days a year, 24 hours, 60 minutes. So that's my effective capacity, but I need to sleep, I need to eat, I need to, unwind, et cetera. And so my actual capacity might be 2,000 hours a year. And you're saying that's the number that we want to make sure we're all aware of, the 2,000. Now, are we hitting that number? We say that that's what we could theoretically do. What else is taking from our time and energy there?
Really good analogy. And we actually measure on both sides. So what are we doing to make sure we're hitting 87? And what are we doing in things like continuous improvement to make 87, 89?
Okay. So using that metric, I really like that because you're right. It is easy to say, hey, CFO, there's going to be 13% unusable capacity. It doesn't matter unless, and then presumably that gives you the ability to say, here's an asset or here's a tool that might be able to increase us from 87 up to 89. Or the reason we're at 85 is because we haven't made investments. Hence, we're now below that number.
Yep, true, exactly. And, I look after the below rail asset, so that's the track, right? The track and the electrification. Then you've got above rail operators who run the trains, and we're both interested in usable capacity. So we also get to have really interesting conversations with each other about what each other are doing to erode that usable capacity. So again, it gives a common language to talk in, which has been really beneficial. Before that, I could talk about speed restrictions. They could talk about what they call plate time, and neither of those meant much to each other.
That's good. That's
Whereas
good.
now we all talk in the same metric. So that's been written. So that's the idea of making sure you've got something that cuts through in your organization is really what helps you get a voice as far as an asset's concerned.
I love that. So two kind of follow-up questions. One is, do you convert that to dollars? So like, for example, do you know what a 0.1% up or down is worth to the business?
We do, but it's a bit of a dark science, that one. Where we see it is really if our above rail operator can run, 2 more trains or 3 more trains in a month. So every train that we see roll past us, it's 108 wagons long, 100 tons heavy, and each train is carrying $1.5 million of revenue in coal. So if you can they can get incremental improvements, which means over the course of a month they can run 3 or 4 more trains. That's a lot of value.
Right. Absolutely.
Yeah. So we do talk about loss. If you've gone from 87 and you're down at 84, that equals X amount of trains, and therefore you can convert that to $1.
Okay. That's good. Without necessarily going into all of your own thinking, but what makes it a little bit of a dark science there? Why is that hard to necessarily pin down?
The word usable, right? So I can create capacity, but if there's not demand to take that capacity up, then it's not actually worth anything. So we talk about theoretical capacity and actually used capacity, right? So, you can do something in your plant or on your asset, which means you increase uptime, but if there's no need for it or no one's there to take it, then it's actually not economically worth anything. So it's that, I can do something which means I can create more train paths. Or the other one is, when you've got a linear asset, unless you can get from your point of origin to your point of destination, you can't use it. So if I do something on a section of railway which makes more capacity in this section, but there's nothing on either side of it, it can't be used. So it's not until you make that capacity for the origin destination path that you actually can realise it.
I see. That's good. That's helpful. The second question is, as you all were talking on that panel or just have thought about this in general, do you think this metric is usable across organizations, or do you think it's unique to yours? And if it's unique, is there another metric that approximates that kind of usable capacity?
I'm sure usable capacity would also be known as uptime in other organizations, but it sort of depends whether uptime is important to your CFO as it is important to you. If you can talk about how often your asset is available and the cost of it being down, then it becomes interesting. When you want to talk about acoustics on a bearing or laser alignment of something, that's interesting to the engineer, it's interesting to the maintainer, but not interesting to the C-suite or interesting to your customers. But if there's an old negotiating technique, if you, then I, right? So in other words, you always get something when you give something. So you don't go, hey, Sebastian, I'll give you this discount, and then hope they give you something back. You say, hey, mate, if you give me 24 months of free support, then I'll give you a 10% increase in cost, right? So you always get something. So similar with this one, if you can say, look, if you want to produce 10% more, then I need to make sure my uptime is at X. And to do that, I need to do this and this. So you're telling them the reason why your investment or the thing you want to measure or the improvement you want to bring is actually going to have benefit to someone else. And I think if you can convert your KPIs into what does it mean for me or what does it mean for you, then that's a real win.
It's good. I want to turn our attention in our last few minutes to, our company does root cause analysis. So I am curious how root cause analysis plays a role in your business when you've got this enormous space that you're covering. How do you use root cause analysis? Is it an important tool for you all?
Yeah. So like I said earlier on, being closed is the worst for us. So fix, don't fail is not an option. When things do break, we get very curious as to why they broke. So if we have a rail break, literally as it sounds, the steel rail has broken in a way that wasn't expected, we will often, we'll take that to a metallurgist and have them actually do the micro examination to understand what caused the defect. We do a lot of work with ultrasonic testing to see whether, to look for micro cracks in the rail. We do a lot of work on measuring gauge. So that is, where the rails are in relation to each other. Because if they start moving, they're tied down with some large concrete sleepers and heavy fastening. So if they're starting to move, there's something going on. And we want to look for the very small issue before it grows into a large issue. One of the things we've turned on recently is a technology called ATIS, Automated Train Inspection System, which is a series of laser measuring devices which are located on a loco. And basically, as the loco moves through the system, it's doing that really finely calibrated measurement of alignment. So the top and line, rails in a straight line, cant, rails on a slope, gauge, how far they are apart, all that kind of measurement. And what we're looking for is we're looking for the defect, and then we've got the defect and we understand against our standard, if the rails are in this geometry, then they're in this level of fault. Okay. And then the geometry determines how long we need to get to that asset before we fix it. So we have maybe an M3 defect. We need to fix that within 3 months. But that's interesting. But what's really interesting is what does that defect look like in 7 days when we roll over it? If it hasn't moved, you don't need to do anything. Like an M3 defect can stay in that state for 1.5 years. Right? Previously, if it was an M3 defect, we would schedule in to do an interventional maintenance in 3 months and go and do it. But what we're realizing is through, looking at the minor defects, often, sometimes you don't actually need to go and do anything at that asset. You're monitoring it, right? So reliability, again, when we think about reliability, what can we do? What do we need to measure? What do we need to focus on to maintain our usable capacity or maybe get an uplift?
It's good.
Yeah, railway turnouts, where, or a switch, as it might be called in North America, where you have a train move from one to the other. That's the asset that fails the most. So they're the ones that we monitor the most as well. And spend a lot of time doing root cause analysis, educating our maintainer why what they're doing is important to keep that uptime. Yeah.
Yeah, and just as you were talking, I'm just envisioning if you check it within 7 days, you now have like a better prediction of how long there's a problem with it, right? And then you do it another 7 days and your prediction is just getting better and better at when it actually needs to get fixed, right?
Yeah.
Because you've got all that data on it.
That's a new system for us. So we've sort of started at the pointy end. What are the D7 defects? Has to be fixed in 7 days. But now we're starting to get into, let's look at the year 1 defects, the Y1 defects. And let's see how long they take to go from Y1 to 6 months. How long does it take that type of defect to grow into something? And then you can go, okay,
right.
Then you can get into really predictive and say, right, based on that degradation pattern, I can pencil in I'm going to need to do something at that stage in 2.5 years. Yeah. As we're learning the system and sort of understanding what's available from it, it's getting more and more exciting.
It's good. That's great. Well, Drew, it's been fascinating talking to you. Thank you so much for your time. I've really enjoyed it. I feel like I could talk to you for a lot longer. I love data and I love talking about how it's analyzed and used effectively. So thanks for sharing how you're doing that. I also really think that usable capacity metric is a really interesting one. It'd almost be interesting to like ask other organizations and other industries to kind of think through what their metric is. And I think the other layer you added just about it's not just enough to have that capacity, but can you actually take advantage of it is another thing to kind of think about creating that formula. So Drew, thanks so much for your time. It's been fascinating talking to you. We really appreciate it. To all the listeners here, we're really about trying to help engineers and really anybody take steps to really use technology and data really to make the world a more reliable place. If you're listening to this podcast and you're interested in RCA training or resources, check out reliability.com. And of course, if you're looking for software, please check out Easy RCA. It's our in-house software that helps you do that. Well, that's all the time we have for today. Thanks again, Drew, for your time. And we really appreciate it. We'll see you on the next episode. Take care.